All right, so let's take a look at this first preparation problem for preparing our battle for Saturn's moon Titan. These I've pulled a lot from, college exams or even SAT 2 questions. So, the real thing here, but also maybe these can help us in our battle. So SO2, as we talked about, is a rotten type of gas. It kind of smells very rotten. That rotten egg smell you get is SO2. And maybe we just want to make the battlefield smell bad so the Batarians just fall over. Like, what's that smell? Anyway, it looks like we're burning pure sulfur in 8 liters of oxygen. So we have supplied 8 liters of oxygen. And we're looking for how many liters of SO2. So right here, we can produce at STP. And I've drawn this box for you guys here just to kind of keep track. And we'll take a look at 2 methods. But here's method 1. Here's the method we've been really hammering out in class. All right, so I know I've got 8 liters here, and I know I need to produce SO2. And it would be nice if I know for every liter of O2 how many liters of SO2 I have. But unfortunately, I don't have that conversion. What I do have, though, is this chemical equation. I know that when I mix 1s with an oxygen of O2, a molecule of O2, I make 1 molecule of SO2. So in other words, this looks balanced already. 1s and 1 O2 makes SO2. So I know if I have 1 of these, I'm going to make 1 of these. And if I have 2 of these, I'm going to make 2 of these. And if I have 3 of these, I'm going to make 3 of these. But I don't know how many O2s are in 8 liters, right? So that seems to be my first task. If I could just get from liters to how many O2 there are, and we'll use moles because I don't want to count in billions upon billions, that might be helpful. And then, as I just said, if I knew that, then I could just quickly go from the moles to the moles of SO2. So for example, if this is 5 moles, then I know, well, hey, with every 1 I make 1, so then this has to be 5 moles as well, and that's going to be our second step. And then the final step is I don't want to know the moles of SO2, I just have one more conversion up to the liters of SO2. Now, because we're at STP, we have a convenient conversion between moles and liters, which is 22.4 liters per 1 mole. 1 mole, okay. And here we also have 22.4 liters per 1 mole, and that applies whenever we're at STP. So we know that if I have 8 liters, I can predict the number of moles. So let's do that real quick. And actually, before I do that, I just want to write out a general plan. Okay, so it looks like my general plan is I'm starting at liters of O2, and I want to convert to moles of O2. And again, the reason I want to convert to moles is because if I know how many moles I have, I can use these coefficients to convert between the amounts, which is going to be the key step here. So then I could go from moles of O2 to the moles of SO2. And from moles of SO2, I can convert back up to liters of SO2. So it looks like we have step 1 here. All right, so I'll start with step 1. I have 8 liters of 8 liters of O2, and I'm going to convert. And I know my liters need to go on the bottom, liters of O2, on top, moles of O2, and I know in 1 mole of O2 I have 22.4 liters of O2, so that's wonderful. And if I do that, I believe I get roughly 0.376 moles. I don't have my calculator with me, but I'm just making a prediction there. Okay, so normally with sig figs, I only have 1 sig figs. I have to round that to 4. So technically, if I were writing in here, it'd be 0.4 moles. But I'm just going to keep this here for now because I know I need further calculation. So I know now I need to calculate step 2. How do I figure out how many moles of SO2 I have? And really, you could just look at this and know, right? Because I know for every 1 mole of O2, I have 1 mole of SO2. So if I have 0.4, I should have 0.4 as well. But if you like the calculation in the mathematical way that will always work is you know you want to get rid of the moles of O2. You know you're converting to the moles of SO2. And you see here that, oh yeah, the moles of O2 and SO2 are in a 1-to-1 ratio. So of course, that's just going to be 0.376 moles of O2. All right, wonderful. Now I know, sorry, not moles of O2, right? The moles of O2 canceled. We have the moles of SO2 here. Great. And now we know, all right, well, I'm at moles of SO2. That's great, but I actually want the liters. So I just need one final step, converting from the moles of O2 to the liters. And because we're at STP, we know 1 mole of anything, SO2, O2, as long as it's a gas, there's 22.4 liters of SO2 in 1 mole of SO2 when we're at standard temperature and pressure. And this is going to be kind of the reverse calculation here. And we get 8 liters, right? Liters is left over, 8 liters of SO2. Now you might be thinking, that looks suspicious. Why are these liters the same? And if you think about it, it makes sense, right? Because if these are in a 1-to-1 ratio, and for every 1 mole, regardless of whether it's O2 or SO2, it's 22.4 liters, then if I have 8 liters of this, I have 8 liters of this. But be very careful. It's not always going to be the same. It depends on your molar ratio. So maybe as we see more examples, that'll become clearer. But there is a connection between the liters and also your coefficients. Because of that, they're both kind of set in that in 1 mole of both of them, there are 22.4 liters. Okay, cool. So that's one method of figuring this out.